Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This video and the others in the Chapter 4 Problem Solving with Python playlist are an introduction to the concepts you will need to write programs with looping or repetition. This video accompanies Problem Solving with Python Chapter 4, but it's okay if you don't have the book. The videos stand alone as instruction on these topics. In the last video, we talked about counting loops or for loops. In this video, we're going to talk about problems that are solved with a loop within a loop, or nested loops. Let's dive in. I have open here in idle a script that you might like to type in so you can follow along with the video. This script is pretty straightforward. It's a while loop that prints the numbers from 0 to 59. It follows our standard loop pattern. Our loop control variable is initialized to 0 before the loop. We loop while the variable is less than 60, and we increment by 1 inside the loop. What's a little different about this loop is that instead of calling the loop control variable I, I've called it second. This loop simulates a clock displaying the seconds from 0 to 59. And just a note, of course there is a way in pretty much any language to get the system clock and display the correct time and increment it each time a second has elapsed. This is not a real clock. I'm using a clock as an example here because it's an example that we're all familiar with, and it has a familiar visual representation that's helpful in understanding nested loops. So let's look at an analog clock. This is one I found online at visnos.com. Now, what do we notice? There is a second hand that moves through the numbers 1 to 59, and then at 60 or 0, the count starts over, but the minute hand moves by 1. Then the second loop starts over at 1 and goes through all the numbers through 59, and at 60 or 0, the minute hand again increments by 1. If we look at the minute hand, it does the same thing. It moves through 1 to 59, and at 60, the hour hand moves by 1, and the minute hand starts over. But each time the minute hand moves 1, the second hand has to move through its 60 values. This is a good example of a nested loop. The minute hand has to wait for the second hand to complete its entire loop before it can take the next step in its loop. So the second hand is a loop that is nested within the minute hand loop. That is what it means. The second hand must complete its entire loop for each single iteration of the minute loop. Going back to our program, let's add a simulated minute hand to this code. I'll annotate a variable called minute of type int. And the minute loop looks just like the second loop, except it's wrapped around the second loop. I'll write, before the second loop, minute equals 0, while minute less than 60, colon. And then I'm going to indent all of the code for the second loop, from the initializer through the updater. And then I'll add the minute updater, minute plus equals 1. That is not inside the second loop, so it's important to get the indentation right. That happens after the second loop code. So the second loop is just part of the minute loop body. Now let's print minute inside the minute loop before we start the second loop. I'll add print minute, comma, minute, and I'll change the second print statement to print second, comma, second. And let's run the program. That's going to run for a while, so we'll skip ahead in the video to when it's done. If we scroll back through the output, we can see second 59, second 58, etc. back through second 0. And before that, it says minute 59. And then second 59, second 58, keep scrolling all the way through second 0, and then it says minute 58. So for each minute, we get the full iteration of the second loop. You can always nest programming structures like loops and the various forms of if statements within other structures. So if statements within if statements, loops within if statements within loops, and loops within loops. When we refer to a nested loop, we are generally referring to a loop like this one in which the structure of the problem requires one loop embedded within another loop, where for every time one loop increments, another must execute fully. So a clock is a good example, and we can add an hour hand to this and have it nested even deeper. A table, like a spreadsheet, is a good example. In the inner loop, we might visit every column, while in the outer loop, we're visiting every row. So we would start with row 1 and visit column A, then column B, then column C, etc. And then we move on to row 2 and visit column A, then column B, then column C, etc. A deck of cards is another example. We might visit every card value from ace through king for the first suit, then we change to the next suit and visit every card value, and then we change to the third suit and visit every card value, then we change to the fourth suit and visit every card value. Thus we could list out all of the cards in a 52 card deck. Let's do another example, and we'll add some code to total values. Suppose we want to obtain hours volunteered on every day for a week, and we want to total those hours. But we want to do that for 4 weeks. Suppose we want to print the total for each week, but then at the end we want to print the total for all 4 weeks. So that's 2 totals. Let's start with the inner loop, the loop for 1 week. We know how to write a loop that obtains 7 values, 1 for each day, and total them. I recommend you pause the video and see if you can write that loop yourself, just to refresh your memory. If you can write that loop yourself right now, it will make the nested version much easier to understand. Okay, I hope you wrote the loop. Let's write it together now. So to start, let's write a loop that iterates 7 times and asks the user for the hours volunteered each day. We'll need a loop control variable to drive our loop. I'm going to call it day because our loop iterates over 7 days. So I'll add a comment, annotate variables, and I'll annotate day, an integer. And then I'll have a comment for the loop, obtain the hours volunteered every day for a week, and total them. We won't total yet though. Okay, so we'll set day equals 0, then while day is less than 7, colon, and then day plus equals 1. That loop will iterate 7 times. Now let's put an input statement in, and we'll get the number of hours volunteered that day. I'll write day hours equals float input. How many hours did you volunteer on day curly braces? And then I'll format and substitute in day plus 1 to the curly braces. So it'll prompt the user for the hours volunteered on days 1 through 7 rather than 0 through 6, which isn't a natural way to count things. People usually start at 1. It's just programmers who start at 0. And let's annotate our day hours variable as a float. Now, if we want to total those hours, we'll need a variable in an accumulator role. Let's call it week total. We'll initialize it to 0 before the loop. And we'll add day hours to it inside the loop. And let's put a print statement after the loop and write the weekly total is curly braces and format week total so we can see what we get. Let's run this, and I'll enter 1 7 times, and we get a total of 7. Okay. Now suppose we want to do this for 4 weeks. Then we'll need to wrap this loop in a loop that runs 4 times. So let's annotate another variable to control our outer loop, and we'll call that one week, and it will also be an integer. It's going to step through the values 0 through 3. So we'll set week equal to 0 before the other code in the program. And then we'll write while week is less than 4. Now we're going to take all of the code that we wrote before, from week total equals 0 through the print statement and indent it within our loop. We'll indent our comment too, of course. And then finally, we need an updater for our outer loop, so we'll write week plus equals 1. Let's add the week to the input statement. So we'll change it to how many hours did you volunteer on day curly braces of week curly braces. And in the format parentheses, we'll pass in for arguments day plus 1, comma, week plus 1. And let's run that. Okay, I'll volunteer 1 hour for every day for week 1, 2 hours for every day of week 2, 3 hours for every day of week 3, and 4 hours for every day of week 4. And I get the expected totals 7, 14, 21, and 28. Looking back at the code, it's important to understand that we are resetting our accumulator each time through the outer loop when we set week total equals 0. Inside the inner loop, we're adding the value entered by the user to the total. Then, after the loop, we're printing it. Then we update the outer loop control variable, week, and execution goes back up to the outer loop header. If week is less than 4, we go into the loop and set week total back to 0. And then we get the next week values from the user and total them. So each time through the inner loop, we're totaling only the values entered while that loop is executing. Now, suppose we want to total those totals. Let's add another accumulator variable. I'll annotate month total of type float. And before the outer loop, we'll set that to 0. Then after each inner loop, either before or after we print the weekly total, I'll put it after, we'll add the weekly total to the month total. Now after the outer loop is done executing, we'll print the monthly total. I'll print the monthly total is curly braces and put month total in the curly braces. Let's run it again with the same values as before. And the weekly totals are as before, and the monthly total is 70. It has added 7 plus 14 plus 21 plus 28. If you look at the structure of the two loops, they're quite identical. In the inner loop, we set the total and the loop control variable to 0 before the loop. Then each time through the loop, we get a value from the user, add it to our total, and increment the loop control variable. When the loop is done, we print the total. In the outer loop, we set the total and loop control variable to 0 before the loop. Then, each time through the loop, we get the weekly total and add it to our accumulator, then increment the loop control variable. After the loop, we print the total. The main difference is that in the inner loop, we're getting a value from the user. In the outer loop, we're getting the value by running the inner loop. When the inner loop is done executing, we have a value that we can add to our outer loop total. I recommend you run this loop in the debugger or in pythontutor.com, which is a great visualization tool, and build an understanding of how this loop is constructed and how it works. As one final note, I want to talk about nested for loops. In these examples, I've nested while loops because it is clear with a while loop when the loop control variable is initialized and updated. It's less clear with a for loop. But all of these loops can be rewritten as for loops, and because we know in advance how many times each loop will execute, a counting loop is a good alternative. Let's rewrite the clock program with a for loop to demonstrate. The outer loop executes 60 times, so we can write for minute in range 60. and then indented print minute, comma minute, and then the inner loop, still indented under the outer loop header, also executes 60 times, so we'll write for second in range 60, and then indented print second, comma second. That's a lot less code, so you might find this simpler. It works the same as the while loop, so the outer loop will begin with minute equal to 0, and then the inner loop will execute a full 60 times before we then increment minute to 1. We then go back in and the inner loop executes a full 60 times, with second taking on the values 0 to 59. Many students find that confusing, which is why I write these loops as while loops first. In the while loop, you can see quite clearly that second is initialized to 0 each time through the outer loop. So the inner loop is always starting off at 0 and running through a full set of iterations. Because the initializer, test, and updater aren't quite as explicit in a for loop, sometimes students don't realize that the for loop also starts over each time we reach it from the top. I'm going to end this video here, and I urge you to practice with this. As I mentioned earlier, it might be helpful to run the examples in the debugger or in pythontutor.com so you can fully understand the flow of control. Try rewriting these examples from scratch, and try writing the summing loops as for loops. Maybe try one of the other natural nested loops that I mentioned, such as the deck of cards example. I've included some auto-graded exercises in the description of this video so you can practice with the video code. Once you've mastered the concepts here, you're ready to move on.